All right, let's dive in. We're going to talk about something you're literally experiencing every single second: sound. It's everywhere, right? But what is it really? How does it get from, say, my voice to your ears? And maybe the biggest question of all: why is the vastness of outer space completely, totally silent? Let's figure it out. Yeah, let's kick things off with that classic sci-fi question. You've seen it in the movies a million times, right? These huge, fiery explosions in space, complete with a massive boom. Well, the reality is nothing, just silence. So why is that? How can two astronauts be floating inches apart and they can't even hear each other speak? That's the puzzle we're going to piece together today. Now, to solve that big cosmic mystery, we actually have to bring things right back down to Earth. See, the answer isn't hiding out there in the void of space. Nope. It's in the physics of every single sound you hear every single day. So what is the secret ingredient? What's the one thing that all sound has in common? Well, it turns out it's a tiny, super fast movement, an action that's happening all around you right now, even as you're listening to me talk. And that secret ingredient is vibration. It's a really simple idea when you break it down, just a quick back and forth wiggle of an object. Think about a guitar string after you pluck it, or a bell when it rings, or even your own vocal cords. That little movement, that's the starting point for every sound in the universe. But hey, don't just take my word for it. Let's look at a really simple experiment that actually lets you see this in action. Okay, so first, imagine we take some of those little lightweight polystyrene pieces and just sprinkle them on a speaker cone. Then, for the action, we send a quick jolt of electricity to that speaker. Ready to see what happens? The instant that speaker makes a sound, boom, the pieces jump and dance all over the place. Now, this simple little demo is actually pretty powerful. It proves that the speaker cone is physically moving, it's vibrating, and that vibration is what's creating the sound and launching those little pieces into the air. So the main takeaway here is really simple, but it's also fundamental. No vibration, no sound. Period. It is the absolute first step. Every single sound, from the quietest whisper to a massive thunderclap, it all starts with something, somewhere, vibrating. And you see this exact principle at play in any orchestra, right? For a guitar, it's the strings vibrating. For a drum, it's that stretched membrane, the skin. And what's cool is for something like a flute, it's not the metal itself making the beautiful note, it's the column of air vibrating inside it. So you've got different objects, but they're all following the same fundamental rule. Okay, so we've established that vibrations create sound. Simple enough. But you know what? That's only half the story. A vibration happening all by itself is pretty useless unless it has some way to get from where it started to your ears. It needs, well, a ride. And that brings us to the next logical question, doesn't it? If sound is just vibrations, how does that vibration travel from the speaker cone all the way to you? Why doesn't it just stay put? Well, it's because sound needs a vehicle. It needs an invisible highway to travel on. And in physics, we have a name for that vehicle. It's called a medium. The medium is basically the stuff, the substance, that carries the vibration from point A to point B, from the source to a receiver. And that medium can be almost anything. It can be a gas, like the air that's all around us right now. It can be a liquid, like water. Or it can even be a solid, like a block of steel. But what can't it be? A vacuum, empty space. It makes sense, right? If there's literally nothing there, there's nothing to carry the vibration. And with that one simple idea, that sound needs a medium, we now have everything we need to finally solve our space mystery. So let's prove it with a classic experiment that makes this concept crystal clear. To do that, we're going to use something called the bell jar. This is just a really clever piece of science that gives us undeniable visual proof of why this whole medium thing is so essential. So the setup is beautifully simple. First, we take an electric bell, something that makes a nice, consistent ringing noise, and we seal it up inside this glass jar. Okay, so for step one, with the jar still full of air, we switch the bell on. And, as you'd expect, we can hear it ringing perfectly. The vibrations are traveling through the air inside, then through the glass, and right to our ears. So far, totally normal. But now comes the crucial part. We attach a vacuum pump to the jar, and we start sucking all of the air out. As that medium, the air, starts to disappear, just listen to what happens to the sound. And just like that, the sound vanishes. The ringing gets fainter and fainter until there's nothing left. We can still see the little hammer on the bell moving back and forth. We know it's still vibrating, but the sound is completely gone. By removing the air, we've taken away its highway. And there it is. That's our answer. A medium is absolutely 100% essential for sound to travel. Space is a vacuum. There's no air, no stuff to act as that highway. So it doesn't matter how big or loud an explosion is in a movie. Without a medium, there are no vibrations to ever reach anyone's ears. It's just complete, total silence. So we've solved the mystery of silent space. Awesome. But the story of the medium has another really fascinating twist. It turns out not all of these sonic highways are created equal. See, the type of medium doesn't just decide if sound can travel, it also decides how fast it gets there. Sound actually has a different speed limit when it's moving through a gas versus a liquid or a solid. And the differences are just staggering. In the air around us, sound chugs along at about 330 meters per second. But put it in water, and it's suddenly moving over 4 times faster. And in a solid like steel, it's a blistering 4,500 meters per second. So why is that? Well, it's because the particles in denser materials are packed way closer together so they can pass that vibration energy along to their neighbors much, much more quickly and efficiently. And you've actually experienced this your whole life without even thinking about it. It's why you always see the flash of lightning before you hear the thunder. Light is just insanely faster than sound traveling through air. It's why in old movies you see people put their ear to the train tracks. You can hear the train coming through the solid rail long before you can hear it through the air. And it's why the underwater world is so incredibly alive with sound for animals like dolphins. So let's end with this thought. We've learned that sound is all about vibration, that it absolutely needs a medium to travel, and that its speed totally depends on what that medium is. So if sound in water is over 4 times faster, clearer, and way more intense than in our world of air, what does the world actually sound like to a dolphin? It's a whole other perception of reality, one we can only begin to imagine. Pretty wild to think about, isn't it?